Observed through the telescope, the surface of the Sun shows dark spots, due, as we know today, to intense magnetic fields that block the convective movement of the underlying layers. These areas, receiving a lesser quantity of energy, have a lower temperature and thus appear darker. Thomas Harriot was the first to observe this phenomenon, which was divulged in a publication by Johann Fabricius in 1611. Galileo had a heated argument on the nature of sunspots with the Jesuit priest Christoph Scheiner, who in 1612, under the pseudonym of Apelles hidden behind his painting, had published 3 letters on the subject. To salvage the Aristotelian dogma of the immutability of the celestial bodies, Scheiner had hypothesized the existence of clusters of small planets orbiting around the Sun, which, interposed between the latter and the Earth, appeared as dark spots against the background of the solar disk. Galileo sustained instead that the phenomenon took place on the surface of the Sun or in its immediate vicinity, attributing the motion of the sunspots from east to west to the rotation of the Sun in a period of about 1 month. To back up this hypothesis, he adduced numerous observational proofs. The spots, in fact, showed no periodicity, appearing and dissolving continuously, even in proximity to the center of the solar disk, assuming irregular shapes that changed from day to day. Furthermore, the movement of a planet orbiting at a great distance from the Sun would have proceeded against this background at a practically constant speed. Galileo had observed, on the contrary, a gradual slowing of the spots as they approached the edge of the Sun, in perfect compliance with the hypothesis that they were contiguous to its surface. Some of the pioneers of telescopic observation made systematic observations of the Sun directly through the telescope without any protection, thus damaging their eyesight, often irreversibly. Galileo adopted instead a method devised by his pupil Benedetto Castelli, which consisted of projecting the image of the Sun through the telescope onto a sheet of paper, placed about 1 meter from the eyepiece. To augment the contrast of the image, it is advisable to darken the room, or at least to apply to the telescope tube a large cardboard shield that attenuates the light coming directly from the Sun. With this method, effective and perfectly safe, it was possible to draw the sunspots with great precision directly on the sheet of paper. For this purpose, Galileo first traced a circle on the sheet, which he placed at a distance from the telescope's eyepiece, where the dimensions of the image of the solar border exactly matched those of the circle previously drawn. The image thus obtained is, however, a mirror image. To obtain a correct representation of the solar disk, the sheet had to be placed frontally, turned over vertically, and then rubbed or traced against the light onto another sheet. The projection method, which was to be widely used later, was adopted also by Christoph Scheiner, who substantially improved the apparatus by providing it with a plane of rest for the sheet of paper, integral with the telescope, and above all, by introducing a new type of mount, known today as the equatorial mounting, which allowed the Sun, once it had been centered in the instrument's field, to be followed in its daily motion by moving a single axis. By means of the telescope, Galileo discovered the existence of a quantity of stars much greater than those observable to the naked eye. In his Sidereus Nuncius, he included 2 engravings, one of the zone of Orion's belt and sword, which, in addition to the stars already known, showed 80 new ones. the other of the Pleiades, with 30 stars invisible to the naked eye. For centuries, philosophers had hotly debated the true nature of the Milky Way, which Galileo revealed with the force of, quote, reasoned experimentation, unquote. Thanks to the telescope, in fact, he demonstrated that it is a mass of innumerable stars, which cannot be individually distinguished by the naked eye.